Okay, so here we're being asked to integrate 5 over x cubed plus 5x dx. And so the first thing that I notice here is that this feels like it's going to be a partial fractions problem just because looking at my denominator, it has a bigger coefficient than my numerator. So it kind of is telling me that I should use partial fractions at some point. Before that, I need to simplify this a little better. So I can rewrite 5 over x cubed plus 5x as 5 over x squared plus 5. I just took out an x. Now if I have 5 over x squared plus 5, if I want to use partial fractions, I'm going to write it right here. Partial fractions. We kind of have to split this up and simplify it. So let's do this. So 5 over x cubed plus 5x is going to be equal to a, right, over, also another thing, I should actually just simplify this. I don't know why I wrote it like that. Let's just write this, what we simplified it to, like so. Okay, so it's going to be equal to a over x plus bx plus c, because we can see that we have an x squared, right? So we should be using the bx plus c. Okay, so we just write that bx plus c all over our x squared plus 5. Alright, so now our next step is to actually simplify this. So we're going to be multiplying this x squared plus 5 with a and this x with bx plus c. So it's going to become 5 is going to be equal, because this is going to get cancelled out. So 5 is going to be equal to a times x squared plus 5 plus bx plus c times the value of x. I put both in brackets because I like it like that. So now what I'm going to do is I'm going to actually, something really cool is going to happen here. I can actually sub in a 0. So if I do x is equal to 0 for this one over here, what's going to happen is this entire thing is just going to become 0. So let's just do that, and then we can just achieve our value of a. Right? So let's do that. So 5 is going to be equal to a times 0 squared plus 5. And this is going to be plus 0 because this entire thing cancels out. So now 5 is going to be equal to 5a, and now if we do this simple algebra, we see that a is equal to a value of 1. Cool. So now we found something cool here. Let's highlight that out. Now we found our value of a. Now we need to find our value of b and c. In order to do this, it's a little bit more tricky as we need to kind of manipulate it in order so that we can get these variables. So let's do this. So we write this 5 is equal to a times x squared plus 5 plus, if we look up here, bx plus c times a value of x. So a good number that I think here would actually be to set our x equal to 1, right? And I think 1 is a really good number for this specific case. So let's see what happens here. And also another thing to understand is that we're going to be using our idea that a is also equal to 1 in this case. We're going to sub this back in so we can use it. So 5 is going to be equal to x squared, oopsies, actually. So it's going to be 1 times 1 squared plus 5 actually, plus b, I'm going to actually simplify this further, so it's going to become bx squared plus cx. So also when then I'm going to sub in my 1 here, so it's going to be b times 1 squared, b times 1 squared plus c times 1. Alright. So now we're going to get 5 is equal to, again, we're going to get a value of 6 here plus b plus c, correct? Now if I move to the other side, we'll see if we move the 6 over here, we're going to get negative 1 is equal to b plus c. Alright, so this is something else that's going to come useful later on as we're solving this problem. Now let me sub in a value of x is equal to negative 1. And you're going to see why this is going to work. So we're going to do 5 is equal to a x squared plus 5 plus bx plus c times x. Now you could basically just continue, right? You could continue from anywhere else. But I'm just going to plug in -1 here. So 5 is equal to 1 times. So you can, what I mean by that, you can continue from another position, or I'm just going to continue from the beginning, right? You don't have to write out all these steps that I'm doing here. It depends on your professor or your teacher, what they want you to do. All right, so let's get to it. So we're going to set our a back to 1. Our x is going to be -1 squared, which doesn't really change anything, plus 5, plus b x plus c. Again, we're gonna simplify this even further. So it's gonna be bx squared plus cx, and if we just jump to what we have right now, this entire thing will be the same as before, 6. So we move to the other side. We're gonna have -1 is going to be equal to a value of, this time our b is gonna change. Will it change? No, it won't actually, because we have an x squared. That was a trick question right there. Since we have an x squared, our 1 is going to remain positive, so b is not going to change. What's going to actually change is our c. You'll see why here. So it's going to be equal to b, it's going to stay the same, plus -c, which is basically equal to -1 is equal to b minus c. Okay. All right. So now we've got these two equations here. I'm going to call this equation 1, that's equation 2. And with these two equations, I'm actually going to manipulate them, okay? I'm going to write a blue line over here, and let's actually manipulate these two equations, kind of like an elimination. All right, so we're going to have -1 is equal to b plus c, and I'm going to line up the other one right underneath, and -1 is equal to b minus c. And now I'm just going to add these two, all right? It's going to be an addition. So -1, -1, you get -2 is going to be equal to 2b, and these c's are going to cancel out. So now we know that b is going to be equal to -2 over 2, which is just -1. So b is equal to -1 in this case. Now for c, we get a similar situation where we can just sub back in our -1 into this equation. So we can use any of these two. I'm going to use this one. So -1 is equal to -1 minus c. We're going to move it to this side. So it's going to be -1 plus 1. So it's going to be 0 is equal to c. So my value of c is 0. So now we found all three of our variables. We found a. I'll show you where a is. A is 1. All right. We have found b is equal to -1 and c is equal to 0. Now all we have to do is plug back into our integral. Right now I've rewritten the integral in simpler terms, right, and I've broken it down to partial fractions. Now we're going to be substituting what I've basically highlighted in yellow. So remember our a was equal to 1. Okay, so let's substitute that back in. And our b was equal to -1. So we're going to have negative x here. And our c was 0, right? So we put -1, x plus 0. C, which was 0, let's put that. C, which is going to be plus 0. But I'm not going to write that down. Okay, so now we can actually take the integral of this entire thing over here. Just move that as well. All right, let's just take the entire, this integral over here. All right, so when I'm taking the integral, so I'm going to do the integral of 1 over x dx plus the integral of -1. I'm going to take the -1 outside, right? I can just take it out of the integral. And I'm going to have x over x squared plus 5 dx. So this first part of my integral kind of broken up. It is really easy, right? If we understand how natural logs work in integration, this is simply just going to be the natural log of modulus x. Oops. And here we're going to actually have to do a u substitution to figure this out. So here I'm going to set my u. Let me do my u. I usually like my u sub in red, so I'm going to do it right here. And I'm going to set my u equal to x squared plus 5. Seems like a good candidate, right? And from here I'm going to set my du. My du is going to become 2x, and we're going to have 2x dx. But that's not really good for me to replace. I want to replace an x dx, right? So it's going to be du over 2 is equal to x dx, which is very good, because now I can replace this entire thing over here with du. and this becomes u. Alright, since we have our du over 2 is equal to x dx, and when we're doing our substitution, we have to move that 2 out. So it's going to be negative half when we move it out, and we're going to have an integral of x, which is going to x dx, which is going to be replaced by du, so it's going to be 1 over u du, and this is going to just become negative half times the natural log of x squared plus 5. Alright, so when I'm rewriting this, I can just get my eraser out here. Let's get that out. This is going to be minus half natural log of x squared plus 5. Remember the modulo signs, and there should be plus c at the very end, and this should be your final answer to this question. That's all the solving.